All right, so Catherine and Deva and Kylie, you guys, this is you guys, girls, right? Okay. So it says there's 700 people in line for a popular amusement park ride when the ride begins in operation in the morning. Once it begins operation, the ride accepts passengers until the park closes 8 hours later. While there's a line, people move onto the ride at a rate of 800 people per hour. The graph above shows the rate R of t at which people arrive at the ride throughout the day. Time t is measured in hours from the time the ride begins operation. How many people arrive at the ride between hours 0 and 3? Show the computation lead to your answer. So what they did was they said, okay, they're looking for the integral from 0 to 3 of r of t dt, and they got 3,200. It looks like they chunked that into a rectangle, another rectangle, and two triangles and added those up. It'd be a little bit better if you wrote out the work for that along with it, but that's fine. I think the picture helps a lot there, but that's the correct answer. So good job on that one. And I love seeing the integral there. They're going to want to see that as part of show the computation. All right. Says that part B is the number of people waiting in line to get on the ride increasing or decreasing from 2 to 3. Justify your answer. So they said the total in line minus the total out of line. So we should give a little bit more justification of this, like your total population is going to be the people in line minus your people that's gotten out of line or removed from line. So if we're looking about increasing or decreasing, we take the derivative, which distributes across the negative, and the number of people, or the rate of people in line is r of t, and the rate in which people are removed from line is 800. So you're basically just looking for where r of t is equal to 800. If we look on our graph, that happens here at t equals 3. So from 2 to 3, r of t is greater than 800, so we should say increasing. So and I would include some of this work to justify how why you care about 800, but that would be the idea. Is everybody okay there? All right. At what time t is the line for the ride the longest? So we already kind of started this here, right? So we set up an equation for the people in line. We took, because we're looking to optimize, because we're looking for the longest, we took the derivative, set it equal to 0. We solved. And now all I want to do is confirm that this is indeed the maximum. So I would do a quick second derivative test here to check. So I can see pretty quickly that the derivative of r of t is negative. So that means that t equals 3 is where maximum occurs at. But I should also check a couple of other things, right? I need to check at 0, at 3, and at 8. So that's the start of the day where this maximum value in the end of the day, because this is really a closed interval situation. It said there's nobody, there's 700 people in line at the start of the day. And then P of 3, to do that, was going to be the 700 that started at the day, plus the 3,200 we did in part A. That's the people that got into line, minus the 2,400 people that'll get out of line because they're getting onto the ride. There's 800 people an hour getting onto the ride. That's 1,500. And then if I did 8, I'm going to have 1,500 plus, I would need this area under the curve, and then whatever that is, and then minus another 800 times 5. end. I forget what that value is, but it's less than 1,500. I just didn't feel like adding this up right now because I apparently forgot to write it down. Is everybody okay? Girls, you happy? Okay. So, and then our last part we didn't get to, it says write but do not solve an equation involving an integral expression of r whose solution gives the earliest time t at which there's no longer a line for the ride. So basically we need this equation equal to 0, right? So I'm going to do, that's the integral from 0 to t of r of x dx minus the integral from 0, well, let's just do this, minus 800 dx, right? That's how many people have accumulated in the line. And we have the 700 at the start of the day. We need to have 0 people in line at the end. And that would be acceptable. Does that feel okay? On to 2. Great. Number 2 says, when a certain grocery store opens, it has 50 pounds of bananas on display. Customers remove bananas from the display at a rate modeled by f of t, measured in pounds per hour. After the store has been open for 3 hours, store employees add bananas to the display at a rate modeled by g of t, where g of t is in pounds per hour. How many pounds of bananas are removed from the store during the first 2 hours? So they said that's the integral from 0 to 2 of, and this is just like f of t. So on the AP exam, you can write, if they name something like f of t, you can just name it f of t. You don't have to write out the whole thing. And then they type that into their calculator. That's the correct answer. Again, it's a little thing to just call it f of t, but it saves you like a minute or 2 during the course of the AP exam. It's probably worth it to just use the names that they're giving you. Part B says find f prime of 7. So that's the correct value. Using correct units, I don't see a unit on here, although I heard Anthony say that this is pounds per hour squared, right? Okay, you guys forgot to write it down. Don't forget to do that kind of stuff. That's easy points you're giving away because there's probably a point for having the unit on it. Then it says, explain what this means in the context of the problem. The rate at which the number of bananas is changing after the store is open. Nope. So I would say that after 7 hours, the rate at which bananas are being removed is decreasing by 8.12. Or you could say the rate of the rate at which bananas are being removed. Did Anthony feel like that's what you should have?
That's probably it is. It is how much the rate of bananas is changing.
Okay, that would have been okay also, right? The rate changing. You need to somehow imply that this is a second derivative. So you needed a rate of a rate somehow written in there. Or the rate changing or the rate decreasing, that all would be acceptable wording. So part B or C then says, what did we say? Is the number of pounds of bananas on display at the table increasing or decreasing at 5? So the total bananas is going to equal 50 minus the removed plus the added. We take the derivative of that. We end up here. So we maybe say B prime sub T, using your notation here, equals that stuff. And you get a negative value. So decreasing, that looks good. And then on D, it says how many pounds are on display at time t equals 8. So you took this same equation, and for B of, or BR, you did the integral from 0 to 8 of, again, this is just f of t. Not wrong to write it all out. And this is just g of t. And that looks good. This is the key here, is that you remember the the employees don't start adding bananas back until 3 hours after the store's been opened. And you got 23 something, and that's good. I think the recommendation here for the AP exam is to give decimal solutions to 3 decimal places, is kind of the recommended. If you have all the work set up there, I don't think they're going to be too picky about how you round, but I think the recommendation is 3 decimal places. So that was good. Everybody okay with this? You see very similar pattern, right, of how this is set up, like in minus out, total equals in minus out. Here it was a little bit different on that one because there was some initial stuff. I guess there's initial stuff on the first one too. Okay. All right, let's see. At an intersection in Thomasville, Oregon, cars turn left at the rate of L of t equals yada, 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 cars per hour from 0 to 18 hours. The graph of L of t is shown above. To the nearest whole number, find the total number of cars turning left at the intersection. So for that, it looks like you guys did this. And that is the right answer. I probably would have rounded up to the nearest whole car, regardless. Or given 3 decimal places, I think is okay, because they did not specify, oh, to the nearest whole number, okay. I rounded mine to 1658. I don't know if I looked at the wrong decimal or if you did,
No,
but.
we did, because I didn't think you could have a whole, like, half a car.
Oh, okay, well it says to the nearest whole number, so you just rounded the wrong place. Wah, wah. Part B says, traffic engineers will consider turn restrictions for L of t equals are greater than or equal to 150 cars per hour. Find all values of t for which L of t is greater than or equal to 150 and compute the average value of L over that interval. Give units of measure. So we did like 150. You know, we found our A's and B's, which it looks like they said was 16.12 and 12.43 was like 12.4, 16.1. And you girls just typed that in your calculator and did like an intersection, right? So we have a function for L of t and they did y equals 150 and they just found the intersection. And then they did the average value for a function. I told them that, no, they didn't remember it either. So the average value formula is 1 over b minus a times the integral from a to b of fx dx. So when they plugged that in, they got 199. And this would be, they didn't give a unit, cars per hour is correct. Oh, stop. Okay. Yeah. Okay. Traffic engineers will install a signal if there is any 2-hour time interval during which the product of the total number of cars turning left and the total number of oncoming cars traveling straight through the intersection is greater than 200,000. In every 2-hour time interval, 500 oncoming cars travel straight through the intersection. Does this intersection require a traffic signal? So I have that like left times straight has to be greater than 200,000. Everybody's okay with that? And we know that the straight is 500 per hour, and then, so that means that 1,000 are gonna come through there straight. Because it's every 2 hours, yep. Right, 2-hour time interval. That's why I did 1,000 instead of 500.
Doesn't it say that every 2 hours, 500 cars?
Oh, yeah, sorry. Okay, so that should be 500. Great. And then that's, if I divide that over, I have like 400 then, right?
Only did 18 hours.
What's that? It's any 2-hour interval inside of the day. I haven't finished yet. So this L then is going to be the integral from some t to some t plus 2 of like L of x dx then, right? Is that okay with you guys? What's the busiest interval in our graph? Was that spot right there. So I'm going to build a 2-hour interval around that because that seems about right. So what did I do? I did 13.3 to 15.3. I just kind of did a guess and checker. And I got, this was about 436, and because that's greater than 400, we need a signal. So again, there wasn't a great way to do that. I just took like, you know, about one less than the 12.4 and about one more. Yeah, I just wanted to try to like group in inside of that interval where you had the average value was on 199. So I took like, found that highest spot, which was something. And then I did like 1 minus that spot and 1 plus that spot. And use that to build my interval. Because I knew that was the busiest time of the day for the left hands. Which is really what I just needed to do, was find the busiest 2-hour stretch of left-hand turns. Does that make sense to you guys? Okay. Are we out of time here? Okay. I'll have the AP solutions for these questions into the OneNote if you look this weekend. I think it'll call like FRQ accumulation key or something. Take a look at those. Again, your FRQ on your test is going to follow the format of one of these 5. So you definitely want to spend some time looking those over, making sure you can do those.
Are we good?
Yeah, you're good to go.
Thank you.
You're welcome, Matthew. Have a good day.